Okay, hi guys. So we'll be starting off from where we left in the previous lecture. We were seeing the calculation of Kp and Kc, and we were taking this hypothetical example. So let's actually get on with it. So suppose we have a reaction which is 2Hi gaseous converting into H2G plus I2G. Okay. So here we can write that the initial moles present, let's say they were A, and initially H2 and I2 were not present, and at equilibrium we can say that A minus 2x mole get converted into the products, and x each of the H2 and I2 get formed. So what would be the concentration? Concentration would be A minus 2x divided by volume of the mixture or the solution, x by v and x by v. This would be the concentration, and total moles at equilibrium would be A minus 2x plus x, which is again A, and pressure would be total pressure of gaseous mixture at equilibrium. So total pressure of gaseous mixture at equilibrium, and V would be the volume of vessel and P of Hi, partial pressure of Hi would be mole fraction of Hi multiplied with total pressure in the vessel. Mole fraction of Hi would be moles of Hi at equilibrium, which is A minus 2x, and total moles at equilibrium would be A, we just saw here, into total pressure would be P. Okay, similarly pressure of H2 would be mole fraction of H2 multiplied with total pressure, and partial pressure of I2 would be mole fraction of I2 multiplied with total pressure. Mole fraction of H2 here is herewith we can write that mole fraction of H2 would be moles of H2 present at equilibrium, which is x, divided by total moles of all compounds present at equilibrium would be A minus 2x plus x, which gave us A, multiplied with P. Similarly, I hope I can write x by A multiplied by P as the partial pressure of I2 as well. So let's talk about Kc here. So Kc would be concentration of products at equilibrium, which is H2I2 divided by Hi squared, and Kp would be nothing but partial pressure of H2 into partial pressure of I2 divided by partial pressure of Hi squared. Okay, so partial pressure, what is the concentration of H2 and I2 at equilibrium? That would be x upon V multiplied with x upon V, and for Hi it would be A minus 2x squared upon V squared. Similarly for Kp we can write that partial pressure of H2 would at equilibrium would be x by A into P. For I2 it would be again x by A into P. For Hi it would be A minus 2x upon P squared. Okay, so from here I can write Kc would be equal to V square, from numerator and denominator get cancelled. We would be getting A minus x square upon A minus 2x square as Kc, and Kp would be again the same term, I wrote it wrong here. This is A minus 2x upon A into P square. Okay, so now A square from numerator and denominator getting cancelled. Similarly the case would be for P, so Kp again would be x square upon A minus 2x square. So we can also see here in the reaction that as delta Ng in this case was 0, Why it was 0? Because what is the stoichiometric coefficient of gaseous products, which is 1 plus 1. What is the stoichiometric coefficient of reactant, which is 2. Delta Ng is 0. That's why Kc would be equals to Kp, and we have also cross verified the same. Okay, so now let's see another example where we have PCl3 plus Cl2 getting converted into at equilibrium PCl5. So let's say initially we had initial moles are there. So these are initial moles A here, B here, and 0 moles here. And at equilibrium, what will happen? What would be the moles present here? Let's say A minus X, here B minus X, and let's say X moles of PCl5 get produced. What would be the concentration of each of the following compounds at equilibrium? So concentration at equilibrium would be A minus X upon V. V is the mass of the vessel, or rather the volume of the vessel, not mass. Pardon me for that. So V is the volume of the vessel, and concentration of each of the following compounds at equilibrium would be the following. And total moles at equilibrium would be A minus X plus B minus X plus C, which is just adding these three terms. So we'll be getting A plus B minus X. Okay. So then what would be the partial pressure? Let's say P is the total pressure of all the gases at equilibrium. So partial pressure of gas A would be mole fraction of A, that would be A minus X, divided by total moles of the products or compounds at equilibrium would be A plus B minus X, multiplied with total pressure. Similarly, partial pressure for B at equilibrium can be written as V minus X over A plus B minus X multiplied with P. Similarly, I can write that partial pressure of C at equilibrium would be nothing but X upon similarly to this, we can write partial pressure of C at equilibrium would be X divided by A plus B minus X multiplied with total pressure of the gaseous mixture. Okay, so Kc in this case would be, if we calculate the Kc value, Kc would come out to be concentration of PCl5 divided by concentration of PCl3 into concentration of Cl2, and Kp would be partial pressure of PCl5 divided by partial pressure of PCl3 multiplied with partial pressure of Cl2. So Kc in this case would be, what is the concentration of PCl5 at equilibrium, which is X upon V. Concentration of PCl5 would be A minus X, PCl3 would be A minus X divided by again V, and for Cl2 it would be B minus X divided by V. And what would the value of Kp? For value of Kp, partial pressure of PCl5 would be mole fraction of PCl5 at equilibrium, which is X upon A plus B minus X multiplied by total pressure divided by partial pressure of PCl3 would be again moles of PCl3 at equilibrium divided by total moles at equilibrium multiplied with P. And for Cl2 again we can write that total moles of Cl2 present at equilibrium would be B minus X, and total moles of all the compounds at equilibrium would be A plus B minus X multiplied by P would give the partial pressure of Cl2. From here we can write, just simplifying this mathematical term, we can write Kc would be X times V divided by A minus X times B minus X. This would be the value of Kc. And what would the value of Kp? So Kp, again we can solve this mathematically, and we can write that Kp would be nothing but x divided by x multiplied with rather a plus b minus x and divided by a minus x and b minus x multiplied with p. So with this we come to the end of this lecture. In the next lecture we will be seeing more examples and we will be calculating Kp and Kcs for the same. Till then, good luck and goodbye.